Hi everyone. Today let's look at the LeetCode problem 213 House Robber 2. Before you look into this problem, I would highly recommend you to look at the House Robber LeetCode problem, that is 198. I have also put the link for the explanation of the solution of House Robber, a LeetCode problem 198 in the video description. Please have a look at it before you do this problem. So now let's go through this problem first. You are a professional robber planning to rob houses along a street. Each house has a certain amount of money stashed. So far it's same as 198. All houses at this place are arranged in a circle. Think this way, in the other place it was arranged linearly in 198. Here you have basically a circular arrangement of houses. Basically you will have a circular array. That means the first house is the neighbor of the last one. So that's the main difference there. As before, it's also seen that the adjacent houses have security systems connected. So if you rob from two adjacent houses, then obviously the security alarm will go off and the robber will get caught. So the question is to find the maximum money the robber can make by ensuring that without getting caught by the police. So that's the background of the problem. Now, to understand this problem, let's take a look at an example here. So if you see here, this is our array and it has, so this is our input. So if you see here, these are the amounts stashed in the houses 1, 2, 3 and 1. Now if you see here, this is a circular arrangement. So basically this house, the last house and the first house are also neighbors. You can solve this basically you have to just understand the trick on how to solve it. You cannot have a solution, maximum solution, where these two are neighbors. So what we can do is first take this part of the array, okay, and calculate, apply the determine the maximum profit which the robber can make by stealing money from these houses, and then find from this one. So that is, so the first one will include the first house also, and the second one will do from house number 1 to the last house, thus avoiding an overlap between these two houses. By determining the max of those two, that will be the maximum money that the robber can get without getting caught by the police. Now if you see here, we can go ahead and use the bottom-up approach which we used for the problem 198. Basically, we'll run the same algorithm 2 times. So the time complexity will be order of n and space complexity will be order of. I'm going to only do the bottom-up approach, okay, of House Robber 1 or the problem 198. Let's first do that one, then it will be much clearer. So I just made a small variation to avoid copying of the arrays. I'm just passing the index range for which we have to do the calculation for the maximum profit. So we will have so these are the indices that we will pass over, taking the same algorithm. Please feel free to look into the video for 198. I have added it this will be low. This is the main difference. We'll be using this low and high basically. I handle the corner case where only one element is there. Low equal to high. Then we can tell return nums of low. What we'll do is we'll temporarily store pre1. Then pre1 is equal to pre1 comma nums of pre2 plus nums of I. Then we will just set pre2 is equal to tmp or the previous pre1 value, and then finally return pre1. Now what we'll do is here we will call this rob1 2 times. So the solution will be max of rob1 comma nums comma, this will be 0 comma nums of dot size -2 comma, because that is the last but one index. Okay, I hope you remember the diagram that I showed earlier in our presentation. Then comma 1 comma size minus minus 1. This ensures that there is no overlap. I think we can also handle this corner case here. If nums dot size not equal to equal to 1, then return nums of 0. Let's just run and see this. Looks good. This looks good. Hope this is clear. Have a good one. Thank you.